Welcome back to the deep dive. Today, we are getting into something really fundamental to, well, almost all of industrial automation.
We're looking at a spec sheet for the NTI E-PST500 pressure sensor transmitter.
And it might look a little dense, but our mission today is pretty simple, right?
That's right. We want to pull out the key info you need to, really get how industrial pressure monitoring works. We're focusing on what these numbers actually mean in the real world.
Exactly. For safety, for reliability. I mean, this sensor is a total workhorse.
It really is. You see it measuring everything from hydraulic oils to some pretty nasty chemicals.
In compressors, pumping systems, big irrigation setups, you name it.
Yeah.
Okay, let's jump in the measurement foundation first.
So operationally, it's pretty straightforward. The specs confirm it works with both gases and liquids. Very versatile.
Okay, but on the topic of safety, I'm looking at three different pressure numbers here, and they are very different. You've got the standard range, which is 0 to 500 psi. Then there's max pressure at 1,000 psi, and then a, frankly, staggering overpressure limit of 2,500 psi.
Right.
Why that huge gap?
That hierarchy is, it's absolutely critical for keeping the system safe and running for a long time.
Yeah.
Think of the 500 psi as your normal, everyday operating zone.
That's the sweet spot.
Exactly. The 1,000 psi, that's the most it can take, constantly without getting damaged or losing its calibration.
And 2,500.
That's the fail-safe. That's the physical limit. You hit that, and the diaphragm inside will probably rupture. We're talking catastrophic failure.
So understanding that distinction is what prevents a very bad day at the plant.
It's what prevents dangerous equipment failures, absolutely.
Okay, so it has to be tough. In these harsh environments, what's the one spec that tells you if the insides are going to survive, say, corrosion?
That would be the wetted materials.
Wetted materials.
Yep. This one uses Type 316L stainless steel. That L is important, stands for low carbon.
Which means?
It means it's highly resistant to corrosion, especially important when you're dealing with aggressive chemicals or hydraulic fluids. It tells you right away this sensor's built to last.
That covers resilience. Let's switch to communication. How does it talk back to the control system?
So the electrical profile is pretty flexible. It needs 10 to 30 volts DC to run.
And why such a wide range?
That's pretty standard for industrial power. It just gives you a lot of flexibility, if the power supply has some noise or you're running really long cables.
And it barely sips power, only 10 milliamps max. The output signal is a clean 0 to 5 volts DC, and wow, the response time is just 300 milliseconds.
Super fast. But here's a really crucial point for anyone planning an installation. This sensor is not strictly plug and play. The spec sheet is clear. It requires the ES5 VDC sensor converter to talk to the main monitoring units.
So you can't just wire it in directly.
You can't, and that's a big deal for budgeting and wiring. It means another component, another potential failure point, and of course an extra cost you have to plan for.
Speaking of installation, the physical side seems easy. It's a standard 12-male NPT connection.
Yep, National Pipe Third. Very common.
And the enclosure rating is NEMA 4X or IP65. What does that rating tell you immediately?
It tells you it's sealed tightly. You can mount it any way you want, and it's protected against dust, powerful water jets, even corrosive stuff.
You could hose the whole thing down.
You absolutely could, and it would just keep working.
Okay, we have to talk about accuracy. It lists 1.0% full scale, or FS, and 0.5% root sum squared, RSS. You mentioned RSS is a better real-world number. Why is that?
Well, RSS is just a much tougher standard. It doesn't just look at one error source. It takes the square root of the sum of the squares of, well, all the error sources, linearity, hysteresis, repeatability.
It bundles them all together.
It bundles them all. So if it meets 0.5% RSS, you know that measurement is extremely reliable in a typical operation.
So what does this reliable tank of a sensor cost? Standard unit is listed at $325.
Right, with a 2-year warranty. But here's where the context gets really interesting. Look at the related model for explosive environments, the intrinsically safe one.
The E-PST500 IS.
That one jumps to $2,600.
Wow, from $325 to $2,600.
And that huge price cap, over $2,000, is the cost of one thing, making absolutely sure a tiny electrical spark can't ignite a gas cloud.
So the takeaway for a plant manager is that this standard sensor is incredibly robust. You've got the 316L steel, the NEMA 4X rating, and it's built for steady, long-term use.
And that's backed up by its stability spec, only 1.0% full-scale drift per year, typically.
It's just really solid.
And that stability is helped by its very low thermal effect. just 11.02% of the full-scale reading for every degree Fahrenheit change. That means your pressure reading stays incredibly consistent, even if the temperature swings.
Right.
Which leaves a question for you to think about. How often do you think sensors measuring something other than pressure need this kind of intense stability compensation? And well, why is pressure measurement often so uniquely sensitive to small changes in temperature? Something to mull over.